Good afternoon. TechNation editor John Wallace here. Today, we will learn more about LifeSpark Medical's SmartTank. The SmartTank makes testing faster, easier, and more efficient while conserving gas. The SmartTank is an all-in-one testing solution for CO2 gas modules and anesthesia machines, including models from GE, Philips, Zoll, Draeger, and many others. It automates the testing process, delivering more accurate results in less time using less gas, all backed by detailed test reports. With its intuitive interface, the SmartTank features preloaded test sequences that guide operators step by step through the testing process. It eliminates the need for separate gas regulators, flow meters, syringes, tubes, pressure gauges, and even service manuals. All the necessary hardware is built right in. It can even assist with patient monitor testing. Okay, it's trivia time. That's right. It's time to give away a multi-tool. So the trivia question today is, what is the Chinese New Year animal for 2025? You can submit your answer using the chat question feature in the dashboard. Now, I want to remind everyone that today's presentation is eligible for 1 CE credit from the ACI. 1 hour after the end of today's broadcast, you will receive an emailed survey. Completing that survey will grant access to a certificate that you can download and print from your computer. We will announce the winner of the trivia question later in the webinar, so stay tuned to find out who won. And we will wrap up the broadcast with a Q&A. Please note that the webinar dashboard includes a questions feature. You can submit your questions for our presenter at any time during the demo, but I will hold all questions till the end. Now, today's presenter is LifeSpark Medical's Brent Waite. Brent, you may begin whenever you are ready.
All right, thanks, John. Glad that you guys are all with us today. As mentioned, my name's Brent Waite. I'm a mechanical engineer with a business degree, and I'm one of the owners of LifeSpark Medical. About 5 years ago, we got some funding from the National Institute of Health to look at gas monitors and how they're tested. What are some of the things we should be doing when testing? And ultimately to develop a device to help facilitate testing. So we're going to go through some of that. Some of this is background information to make sure we're on the same page and to help cover the requirements for the CE. And we're going to talk today about why capnometry is important. We're going to look at a little bit about gas monitors. We're going to look at what capnometry actually is. And then we're going to look at common failure modes, how they fail, and what's the result of those failures. We're going to look at best practices, and then we're going to end with a demo of the SmartTank to show you how it can really streamline and facilitate all your gas monitor testing. So that's what we're going to be doing. Hopefully you don't fall asleep today. If you have questions, like you said, please submit them. We love to answer questions, and we'll try to get to them at the end. So you may know some of this, but gas monitor 101, gas monitors, capnometers specifically, measure the CO2 concentration in a patient's breath. They're commonly called end-tidal modules, gas modules, CO2 modules, capnometers. There's a bunch of names. They can be standalone units, or they can be modules in other devices. And these are just some of the common ones that are out there. You're probably familiar with some of these. You probably have them in your shops or your facilities. There's a different class of gas monitors, which are the anesthesia gas monitors. They work in the same basic principle, but an anesthesia monitor, measures not only CO2, but also oxygen, nitrous oxide, which is laughing gas, and anesthetic agent. And most anesthesia monitors will also produce a waveform for each of those gases. We'll talk a little bit about that in a minute. Now, I want to be sure that you realize we're talking about gas monitors and not gas vaporizers. So gas vaporizers are the devices on the anesthetic bench that you put the liquid anesthetic agent in, and it vaporizes that agent into a gas, and then the patient inhales it. We're talking about the other end of it, where the monitor is then sampling the breath they exhale and analyzing what's in that sample to determine how much CO2, O2, or anesthetic agent is actually in their breath. So that's the device we're talking about, the monitor side of it, where it's sampling. Again, here's some common examples of the anesthesia monitors that are out there. If you do anesthesia equipment, you've probably seen some of these. So ultimately, where do we find gas monitors? They're really found everywhere these days. Again, they can be standalone. You really only see this in smaller facilities or, smaller departments. You see a lot of them now as plugins to patient monitors. GE, Philips, every patient monitor offers an option for this. Starting to see them a lot more on infusion pumps. Alaris is doing that. Defibrillators now almost always have some kind of CO2 option. Of course, the anesthesia machines. And so you're finding these really in, operating rooms, ERs, ambulance, all the departments. Even dentist offices have them these days. Transports all have them, surgical centers. It's pretty common. We'll talk about why that is here in a second. So now that we know they're everywhere, let's understand what capnography actually is to make sure we're on the same page there. So again, it's the monitoring of the exhaled carbon dioxide typically, or capnometry is specifically the end tidal CO2 value. This is usually a number, so this is like 32. If you've worked on these, there's usually a number in that 28 to 34 range, depending on your atmospheric pressure. Capnography is actually the waveform that's produced when you monitor CO2 real time. This is an example. The red circle there actually denotes where the end tidal CO2 is measured. It's at the very end of the exhalation, right before the patient starts to inspire or breathe in, and that's the actual end tidal CO2. This graph is called a capnogram. So not all CO2 modules will produce a capnogram, but most of them will, and all anesthesia devices typically do. Now, I just want to point out that this is not the same thing as pulse ox. I point this stuff out because in talking to people, they typically get some of the stuff mixed up. So I just want to make sure we're on the same page. Pulse ox is measuring your oxygen. That's the little thing you clip on the finger and it measures how much oxygen is in your blood. So we oftentimes will talk about analogy. In a gas engine, you take gasoline and oxygen, you mix them, combust it together, you get energy for the car to move, but you also get a waste gas, which is carbon monoxide. In the human body, it's very similar. You actually take glucose and oxygen and put it through the citric acid cycle. You get energy for all your cells, and the waste gas there is carbon dioxide. And so really CO2 provides this instant assessment of the respiratory health by directly measuring the waste gases, right? If your citric acid cycle is not working properly for some reason, then you're going to know that based on the exhaust gases that are produced. Whereas pulse ox is just telling you how much oxygen is in the blood. So you can have all the blood in the world in your oxygen, but if you can't actually use it and convert it into CO2, you're going to be in distress. And that's why CO2 really is the best way to assess respiratory health, or capnography. So to the trained medical professionals, you can identify specific issues and find corrections for them and help the patient. So these are just examples of different waveforms and different things that can be identified based on what that waveform looks like. I don't expect any of us to really know this. I'm just trying to point out that these graphs are important to respiratory therapists, doctors, and others, anesthesiologists, because they rely on knowing what the shape looks like to know how to interact and intercede and help, provide the proper care for patients. So it really is of great clinical value, and clinicians have really embraced it a lot over the last 10, 15 years. Part of that is because there's been a large number of changes in the standard of care and also association guidelines over the last 2 decades, because it really is this best indicator. Here's just a small list of the changes that have happened. This list is like 4 times bigger than this, but these are the big ones. Essentially now, anytime a patient is having CPR, having a cardiac event, receiving any kind of pain drugs through an IV, being sedated, intubated, or on a ventilator, they're supposed to be on a capnometer, some kind of CO2 monitor, any kind of sedation. And so that's why you're seeing this more and more spread throughout. So, for example, in a dentist's office, you used to be able to go in and get laughing gas, and they didn't put you on a monitor. But now, pretty much every dentist will have CO2 in their dentist's office, and they'll put a monitor on you while you're just receiving laughing gas. So ultimately, how does this affect this group, these clinical engineering departments? Well, one, because it's relied on to help treat patients, you really need to make sure that they're working properly under this wide range of conditions. It's no longer just the ER or the OR where you see these devices. And so now you're having to make sure these devices work in all these other locations and all these other conditions. And now you have different types of devices. It's not just one. It's, again, can be on your defibrillator or on your IV pumps. It's also a larger number of devices in the hospitals. Some hospitals have hundreds of these devices now. And so now you have a much larger PM burden. You need to make sure that your PMs are adequate, that you're doing a good job testing, but you got to be efficient to get through it all, because some of the PMs can be time intensive. And so I'm going to shift to a point here where we start talking about some of the failure modes for gas monitors. They fail in a number of ways. They can be out of calibration. You can have poor sampling. We're going to talk about not each one, but most of these in detail here. You can have leaks in the system, which affect readings. You can have a number of mechanical problems or other things that need replaced or serviced within it. And so let's talk about first poor sampling. So you get poor sampling. So about 80% of all the gas monitors out there are what we call side stream, where they just sample a small portion of the breath being exhaled. They've got a pump in them. The other kind is like an on-airway or mainstream, and everything they exhale goes through a bigger device on the breathing circuit. Those are a much smaller percentage of devices out there. So in these side stream ones, your pump can become weak or defective, pulling in either too small of a sample or no sample at all. And so you really need to make sure that that pump's working. It can also be due to plugged filters or partially blocked lines within the device. Typical flow rates for these devices for any of these gas monitors range anywhere from 30 milliliters a minute all the way up to over 200 for anesthesia equipment. There's some as high as 250. All the newest ones are what they call LoFlow. So it used to be 50 was kind of low, and now you're getting down to the 30. And I think there's even some now that are kind of targeting 20. So if you have poor sampling, you can really get a delay in the response. So it's just lagging way behind because you're not really getting the sample through this long tube fast enough, or you can get incorrect readings because you're not getting enough sample in a fast enough time. And so really the best practice for looking for failures in the sampling area is really to always check the sample rate. And you need to make sure you're using an adequate flow meter. So as part of this funding from NIH, we went into dozens of biomedical shops and interviewed them and watched them and just kind of looked at how people were doing testing and again, looking for best practices. And one thing we noticed is a lot of people are using a flow meter that's not adequate to check these low flow rates. If you're using a flow meter that's used for vent testing, it's not accurate enough to test down in this 30 milliliter a minute range. You really need a flow meter that's kind of designed for these lower flows. So we see that missing in a lot of shops. Another big failure mode that we see a lot of or saw a lot of are leaks. And we have a poll here. Let them launch that, and you guys can take that poll real fast.
All right, so the poll question is, do you test for leaks on your gas? Please select one, yes or no. And we have some answers coming in right now. And All right, Brent, 75% said yes, they do test for leaks, and 25% said no.
Great. I got to get back into my presentation here. There we go. Well, that's good. That's good to hear that 75% are doing leak testing. We did not see quite that high, but that's great. So the problem with leaks is, especially if it's upstream, which is the low pressure side, upstream of the pump and the sensor, is those leaks can dilute out the sample, right? So you're essentially sucking room air in with the sample from the patient, and you're getting lower results than you should be. And so that's a problem. Here's an example. We actually did some testing again with the NIH to look at the effect of leaks, measured leaks on 5 different devices. So we actually introduced different size leaks into the system to see what the effect is. So again, every one of these devices will have a different flow rate, but even at just 2 milliliter minute leak, you're already starting to get off 2, 3, 4% almost in some cases. And by the time you get up to 3, 4 milliliters a minute, you're up past 6, 7% off. Now this blue line over here actually is an anesthesia device. And remember, anesthesia devices are much higher flow rates, so they're at 200, 250. And so they're not as affected by little leaks, but 6 milliliters out of 200 is not a very big percentage. So even a small leak in that scenario can cause your numbers to be off. So what happens though is you might recalibrate it with this leak and it will calibrate just fine. And so maybe it's working fine for some of the normal cases, but as soon as you put it on a mechanically ventilated patient, now all of a sudden the use case is totally different and you've got higher pressures going on, and now you're actually going to have problems there too. And so that's why it's important to always make sure you do a full leak check on your devices. Some of them are easier to do than others. I know the GE devices are a pain to do because you have to kind of take them apart, but it still should be done because leaks can really affect the performance of the device. All right, so barometric pressure is another one. We see some issues here. Barometric pressure, every device has a sensor in it to measure barometric pressure. That's what allows them to convert from volume percent to the partial pressure. So for example, 5% CO2, which is what the sensor is actually reading, at 600 millimeters of mercury, that's going to give you a reading of that 30 millimeters of mercury. So that's the reading that doctor's actually going to see. And so we usually will at least verify the the barometric pressure. A lot of times they'll also let you calibrate it. It just depends on the technology and the device, but you should probably always be checking the barometric pressure. You guys also have probably used barometric pressure to do the same math conversion when you're trying to spot check something to get it from, if you're using 5% CO2 gas, how do you get it to this partial pressure? Well, you have to do that same math. But what we found in the researching and talking to people is a lot of clinical engineers don't realize that all the barometric pressures coming from websites is corrected to sea level. So if you're getting on and checking the weather pressure, those aren't accurate, absolute barometric pressures. And so you're actually off. You're off 26 millimeters of mercury total per 1,000 feet. And so you can end up calibrating your device incorrectly if you're using those readings. So for example, if you're at 1,000 feet, you're off by about 4%. By the time you get to 4,000 feet, you're off by 16%. So if you're at sea level, you're probably okay. Still would be better to have an absolute gauge, but if you're not at sea level, you should definitely be using some kind of gauge in your shop to determine that. And so this feeds into the last one I want to talk about, which is the failure mode of just being out of calibration. So this is talking about the actual sensor within the device. We saw and have heard stories and interviewed people where they just used their own gas to do the calibration. It happens. They might be testing device A over here and they go over to test device B and just use the same gas for both, but most of the time the OEMs will call out a very specific gas you're supposed to use. They deliver the gas in correctly during calibration. So this has to do with getting the gas out of the bottle down to room pressure and then letting the pump suck that gas in without increasing the pressure in the sample line. if you force it down that sample line and calibrate it, that can give you erroneous results. Not waiting long enough for warm-up time. That's not to make your life inconvenient. It really does need warm-up time to get those sensors, the way those sensors work, they have to warm up in order to be accurate. And so when it says wait 20 minutes, they really do need you to wait 20 minutes if you're trying to calibrate it. And then again, we talked about using the wrong barometric pressure. So of course, best practice, make sure you use the right gas, let it warm up, make sure you deliver the gas properly. So as we've talked about, I'm kind of wrapping up this part of it, and we'll get to the demo here. Gas modules really provide medical staff vital detailed information. But seemingly small, what to you might be like, oh, it's close enough, or it's close, really can impact performance a lot more than you might expect. So ideal testing methods really are defined in service manuals. In our research, we came up with some other tests that would be great to do, but really the OEMs spend years developing these technologies, and they know where they're going to fail, and that's why they put them in the service manual, these tests, because they want to make sure that the devices are working properly. So we really just need to use what's in the service manual, if at all possible. We did not discover any new additional tests that would be any better than what's in the service manual. So for proper testing though, you do really need a variety of equipment. We found a lot of places don't have that equipment. There are always going to be lots of steps that you have to do. Some devices are worse than others, and they really unfortunately take a bit of time to get through, especially if you're doing it all by hand. As we went out, we talked to people, and what we found was many shops only calibrate CO2 with calibration gas. They might breathe into it, and that's about all they do, which shocked us because of the risk that they're incurring when not doing the testing properly. They often skip the flow and leak test. That's very common. That's why I was happy to hear that 75% of you are doing leak testing. They, like I said, use that adjusted barometric pressure, or they don't have the right equipment, usually specifically flow meters. They're using the wrong kind of flow meter, or the wrong range flow meter, essentially. When we asked them why they do this, we heard different things like, oh, it's too complex, or I don't know how to do all that, but Bob does, and Bob couldn't do it, so I'm doing it, and I just cut it down. Or they don't have enough time. They got too many devices to test because there's just so many of them now. Instead of having 10 in the facility, there's 150 of them or 200 of them. Or they just kind of thought, oh, these are just CO2 monitors. Nobody really cares. It's not a big deal. And that's incorrect. So I'm hoping that didn't put you to sleep, first off. I'm also hoping that you take away from this the importance of CO2 monitors, that you really need to do the PMs properly. What we did is we did all this research, interviewed all these people, we watched people do it, and we kind of came away with where some of the problems were with the time and the complexity, and we put that into developing the SmartTank, which is what we're going to show you now. I'm going to give you an overview real fast here in the presentation, then we'll switch to a live demo. So this is a picture of the SmartTank. This is the only device ever designed specifically to do gas monitor PMs. Couple ports on the front, this A and B port, there's a touch screen. The device has little flip down legs, so you put it on your desk, or you can put it up in this, this image down here on the right, bottom right. You can put it on its back and put it on a cart. A lot of people just cart it around and do their thing. It also comes with a carry case you can put over your shoulder and just carry it around with you, depending on how you do the testing. The customers, our customers love it, and they're always using it. Like, a lot of them bought it thinking they'd use it once a year for their PMs, but they use it for everything to do with gas monitors, to spot check, and find other uses for it too even. On the side over here, there is a hole, a slot to put in a bottle of gas. So you do have to use a gas bottle. The calibration gas is always the best way to calibrate any sensor, no matter what it is, because nothing is more accurate than calibration gas. You can't like mix gases on the fly real time to do a good job, but you should use a calibration gas. So they go in there and they get stored. That's kind of why the size of the device is the way it is. It actually keeps the bottle inside and protects it. There's a USB port here. This is used to retrieve test reports, and we'll talk about that in a second. And there's a plug to charge the battery. It will run all day on battery. You easily get 9 hours or more out of it to do testing all day long out on the floor or in your shop, wherever you might be going. So real fast on this demo today, there's the way we have it set up. I've got this little yellow device, which is a microstream. It's the same technology that's in the Philips 3015A. I've got port A hooked up to this orange sample line, and I'll have the exhaust port over here on this device connected over here to port B. We do that on certain devices. We can actually do a leak test that we developed. That's a lot faster than like a leak down test and does a really good job. But the SmartTank can also do a leak down test, but today we'll show you this method. So at this point, I got to switch over to a live view. So give me 1 second here. Get that to go away. So you should be looking at my camera mostly now. I'm going to switch over to this. I got to move this camera. Sorry, bear with me. Turn this on. I always forget to turn that on, and then that's a problem. So hopefully you can see this well enough. All right. So I've got the SmartTank here. You're seeing the touch screen on the SmartTank. I already kind of explained how it's hooked up. I'm going to use this yellow microstream today as a surrogate for a 3015A. So the SmartTank revolves around what we call test sequences. These test sequences are designed and built specifically for different models and versions of devices. So all you do is come here. If you come into this screen here, you can see all the different test sequences. There's all sorts of devices in here, GE. Anyway, they're not even all on here. For most of them, we have a full sequence or a simple sequence. The full sequence is everything that's in the service manual exactly as the OEM described it. And then we provide simplified ones that have the key things you should do at a minimum. It's really up to you which one you do. It kind of depends on your processes and what you want. So with the test sequences, our commitment to customers is we will always, for life, help you create new test sequences for any devices that come out or that we don't have. We just ask you to help us get a copy of the service manual and help us test the sequence to make sure it's accurate. We just don't have all these devices. In the same manner, if there's a sequence on here, let's say you love the 3015A full sequence, but you want to take 2 steps out or add 3 steps, we will modify those test sequences for free for life. So there's never a charge for that. It's as simple as telling us what you want. We'll create the sequence, email it to you, and you drop it on the SmartTank through the USB, and it will show up here or replace the one that's on there, and away you go. So today, for this demo, I picked this 3015A, simple one. It's the simplest sequence we possibly have. There's only 3 test steps. And so for a demo, it shows you kind of what the SmartTank can do, but it gives you an example. So once I pick that, I'm gonna hit load. I'll hit start. Now, since I'm using this microstream yellow device over here, we won't actually be doing all the steps directly. We'll just simulate it. A lot of that's just to facilitate it and make it go faster so you guys can get done. So this is saying I need a certain gas, 5%, 21%. The SmartTank knows what's in it. I already have a gas bottle. If I click on that, it'll tell me exactly what's in here. That's the 5%, 21%. I've got 255 PSI of gas in there right now, so I'm good there. If I have the wrong gas in here, it will tell me, and it will not let me proceed through some of the steps until I put the right or correct gas bottle in it. Some sequences call for changing out from 5% to 10% or some other secondary gas, and again, it will make sure you do that correctly. Even the information on the gas bottle, like expiration date, lot number, all goes into the test report, and so it can track that. So I'm gonna get next here. It wants an asset ID for the device I'm testing. I'm just gonna put something in there. You put the initials, my initials are in there already, who's doing the test. All this goes in the test report. This screen tells you the part number, publication date, and page of the service manual we use to create this sequence. So you could always go back and refer to that. But our goal with test sequences is to put all the details into it that you need to do it without the service manual. Ultimately, though, you guys are responsible to make sure you're testing it properly. So just a little disclaimer there, verifying what device you should be using, how often. So in this case, it's every year or 4,000 hours. And now we get to the very first test. There's 3 tests in the sequence, the barometric pressures being the first one. And it's telling me to enter the service mode, then select CO2 menu. Now, if you're not familiar with how to do this, you might be like, oh, how do I do that? Well, these little stars on here say, hey, there's more information. So all the sequences, we try to put the bare minimum on the screen, but then if there's a lot of detail that you might need, if you're new to it, or it's been a year since you've done it or something, then you can always go down here to the info screen. And this will actually tell you how to, like in this case, navigate to a specific screen to get to where you need to be. In this case, it even has the passcode in there. So again, the goal is to prevent you from having to go find a service manual. But if you do this 5 times a day and you know it all by heart, then you don't have to dive into these info screens. You can just go through these screens as fast as you want. So in this case, we're not going to actually do this. I'm not going to move the yellow over to get a reading. But it's asking me to enter this barometric pressure that would be on the 3015A screen. We're just simulating this. And it's telling me it wants 681 plus or minus 12. Well, that 681 comes from a barometric pressure sensor that's inside the SmartTank. And so it knows what it should be. And so you can use that as a reference or a check. Now, to help you understand sequences, I'm going to show you what happens when you fail it. So if I enter this as 650, let's say, you'll notice it fails. And now I hit next, and the sequence is smart enough to say, hey, you failed that. You can calibrate this device. You need to calibrate it. Here's the steps. It'll even give you the reference value you should be using when you do the calibration. If you go through this failure, calibration, and then recheck, all that shows up in the test report to show you did it. But the sequences are smart. So if I go back and I pass this test, let's say I put in 680. Now I've passed the test. Basically, it's in spec, and I hit next. The sequence knows that you passed that, and it will just skip the steps that you don't need to do. So again, the goal of the SmartTank is to make your PMs as fast and as efficient as possible. And so you'll be able to just skip through all that stuff. You don't have to go through and say skip or next. It just knows, and it'll just move on. Now, let's say though, in your facility, you always want to recalibrate it. Again, we can tweak the sequences to force somebody to go through that calibration if that's something you want to do. So now we're on step 2. This is the second test in this little sequence. We're going to check the flow rate. So remember, I had the sample line and the exhaust hooked up. I'm going to hit start. This will take about 12 seconds. The built-in flow meter is very accurate. It can measure all the way down to about 0.5 milliliter a minute. All the way up over 200. And so it will go ahead and check the flow rate of the device. And in this case, since I had that exhaust port hooked up, it's going to check for leaks using a faster leak checking method. So you'll see here it finished. Oh, let's see if I can get it to focus. There it goes. You're at about 45.3 milliliters a minute, so that passed, and the leak is less than our limited detection. So again, that's that 0.5 milliliter a minute. So essentially, there's no leak that we could even detect with our sensitive flow meter. And so you pass. That's it. You're done. All this will go in the test report. You can move on. You don't have to get out your flow meter and redo the setup. I haven't changed any of the setup from what I showed you. So it just moves on. And now we get to the last thing, which is the CO2 calibration. Again, it's suggesting 20 minutes. I'm not going to calibrate, so we'll simulate this. It's telling you to go to a certain module and to get to a certain screen. And then at this point, it's saying, hey, when instructed to turn on the CO2 or deliver gas, go ahead and touch cal on. So I'm going to do that. If you watch the yellow device over here, you'll see it actually come up on the graph where it's actually getting CO2 gas now. So one of the things we heard from everybody we talked to is, can you save us gas? We use way too much gas, it's expensive. And so we really designed the SmartTank to use as little gas as possible. So in reality, we use the flow meter inside the gas to measure how much gas the device needs and to deliver just a little bit more. So if you remember, we measured the flow at about 45 milliliters a minute. So we're giving it about 46, 47 milliliters a minute. That way, you know, it's not, if you use a regulator and crack it, you're using 200 to 300 milliliters a minute minimum. There's no real way to not use that much gas. So this is using a sixth of the gas. The other thing we did is this little countdown timer. You'll notice it's about to turn itself off automatically. You can adjust how long that is, but that's in case you get distracted, walk away, you're not gonna burn through an entire bottle of gas. So our customers have told us they easily use way less gas than they used to, and they love that feature. So in this case, on this screen, I must have jumped. No, I didn't. Sorry. Oh, I did. There you go. So on this screen now, it's asking us to confirm what the value would be over here. Again, it doesn't show a value because I'm not in the right mode. It has to be breathing to get it in this mode. Anyway, we'll pretend like it's this 34, so it passes. Well, if you're paying attention, you'll notice that, hey, wait, where'd that 34 come from? I'm using 5% CO2. Well, the SmartTank does all the math for you. It uses that absolute pressure sensor, just converts it. I might come back in a week and this will be 32% instead of 34 because the weather's changed or something else. So we're done. I'm done with the cal check. That was fast. Again, I didn't even have to get a regulator. I didn't have to change my tubing. I didn't have that little bag and that menagerie of stuff that you have to get the pressure right. The SmartTank has a manifold built into it and it'll get the pressure down to atmospheric pressure automatically. At this point, I hit next and I'm done. It says I passed everything. It will generate a test report. This test report will have everything that I did, who did the test, what device I tested, all the values I entered, all the values the SmartTank measured, all the screens I went through. So in this case, I entered that 680 in and it was supposed to be 681.2 pass-fail criteria. There's the flow test where it measured at 45.3. It's interesting, this used to read about 50 and over the last year or two, it's slowly dropping closer to the point where it's failing. I don't know if we're wearing the pump out, but that's kind of been interesting to watch. And so this test report will have everything in it. If I hit done, I go back to this main screen. I can always go get the report again here and see all the reports, store them on the SmartTank, or I can hook a USB up to it. Once you connect the SmartTank to a USB on a computer or a smartphone, it just becomes a mass thumb drive, like mass storage thumb drive. You go in, grab the report or reports you want. You can download them, you can email them to yourself. So some customers have a hard time because their computer, IT locks their computer out. They just use their phone to do that and they email it to themselves from the phone at the end of the day, or you can do it for everyone. The test reports are simple text files, very small. You can store 50 years worth of tests on the SmartTank if you want. Those test files, a lot of people will copy and paste them into text fields within their MMS or their work reports or attach them as files. Some just choose to store them on the SmartTank. So it really depends on the requirements of where you're at. And so now at this point, if I had another device, hopefully I turned it on 20 minutes ago, but I can just go in, repeat the same test sequence and move forward. Once you get really good at a sequence, you can actually use this detail level right here and change it to brief. And what happens there is in the brief version of a sequence, you skip all the information screens and go straight to the screens where you have to enter data or the SmartTank needs to measure something. So it's just another way, if you're doing like dozens of these a day, you can just speed it up really fast and not have to go through all these screens. But if you haven't done it in a while, you can just turn on the full detail level and then it will guide you through stuff a little more directly. Usually I stop here for questions, but since they're written, I'm gonna keep going. We're almost done with this demo. There are a couple of single test modes you can repeat. So for example, if I wanna just test a machine on, let's say I repaired something, I just wanna check flow and leak to make sure there's no issues. I can go in and run that flow and leak test again that we had before without running the entire sequence. I'll still get a test report. I can set the pass-fail criteria to what I want, run that test, and away we go. But also, you can do a breath simulation, just deliver calibration gas, a couple of other tests. You can do a leak down test. So the leak down test is basically where you pressurize and wait 30 seconds or a minute to see what the pressure change is on the device to see if there's a leak. The SmartTank will do that all for you automatically. Some of the sequences use that. So for example, the Philips 3015A full sequence, which is the entire sequence as is defined in the service manual, uses a leak down method rather than our faster little exhaust gas method. And so it will do that for you. It'll guide you through it. It'll do all the measurements, all the timing. It'll check for stability. And so it really just facilitates that whole process. Because we did the leak down test and have that ability to do a leak down test, which is heavily involved in non-invasive blood pressure cuffs, we added this pressure relief test. So with the SmartTank, you can actually do all your non-invasive blood pressure test cuff testing and device testing. It has all the modes you need for that. In fact, we have test sequences for many of the patient monitors that are out there. And if not, we can write them. Essentially, you would still need your your EKG tester and some of the if you're doing temperature testing, you'd need those devices to do the test, but the SmartTank will walk you through them and collect those results from you. And then when it gets to non-invasive blood pressure, it'll actually do that testing for you for the most part. And in the end, you get a test report of all your patient monitor testing. So we're trying to allow the SmartTank to do more testing than just CO2 modules. And again, we'll write, if you say, hey, I want to test this device and use the sequences for that, and we don't have a sequence, we'll write it for you. So the final thing I want to show you is there are some manual modes too. Gives you the flow meter. So as long as you're in that minus 250 to 250 range, you can use the flow meter to check flow on any device. Just don't use liquid through it. It's not made for liquid. You can see my device is still running and it's flowing around that 45. It's got a manometer built into it, so it can actually measure pressure or vacuum up to 450 millimeters of mercury. In this case, it's drawing a vacuum because I'm drawing that sample out, and you can see where that's at. If you need a barometer for something else, you can always see what the barometer reading is. All three of these devices are NIST traceable, and when you send it in for your annual servicing, all three of those are calibrated for a single fee and come back as calibrated each year. So the last thing is this breath simulation. This is kind of nice if you want to go out and check something. I'm going to start this, and if you watch the yellow device over here, you'll see that it starts to, the SmartTank will simulate a patient breathing. It will actually give you the respiratory rate here in a second as it comes up, and it will give you the end tidal value. If you look at the SmartTank, it's expecting 34 and 20 breaths per minute. And so there it goes. So 20 breaths per minute and 34. And so this is great if you want to go out and spot check something, a nurse or somebody calls up, I don't know if this is working, you can run out there and just check it and show them, or any kind of testing. It can be worked into a sequence too, but it's a great little extra tool. Turn that off. I think that's about it on the demo side. Again, our patients have found a lot of use for this, not our patients, our customers have found a lot of use for this. We've had hospitals and buy one for a facility, and we'll have the entire, all of their hospitals come back within a year and buy one or two for all their facilities typically, because it just ends up saving so much time, makes it efficient. You don't have to have Bob do all of them because he knows how to do them. You can give this to the newest guy and he'll be able to figure it out. And again, saves you gas. And then you get all these test reports. And so it really streamlines that process. So I think at this point we could take some questions if there are any. Hopefully nobody's passed out due to boredom.
No, nobody's passed out, I feel certain. We do have some questions.
Great.
One question is, can the SmartTank help test anesthesia monitors?
Correct. So the anesthesia monitor, yes, not the vaporizer. So people get confused on that. It's not going to analyze the vaporizer and its output. What some of our customers will do is calibrate their monitor and then use the monitor to check the vaporizer. Knowing that they just calibrated it, they'll use that as the sensor to check their vaporizer. So the only thing is you have to just change the bottle out to the right gas in order to do the anesthesia monitor testing. They're usually a lot more complex. Some of those sequences will have 20 or 30 steps in them, 8 or 10 different tests, because you're doing full leak tests, you're doing flow rate tests, you're basically calibrating or checking each gas independently. And so the SmartTank will definitely facilitate all that. Great question.
Another question we had, I think you may have touched on this, but it's worth talking about again. What if we can't find a test sequence for one of our devices?
Great question. So our commitment is we will create, edit, modify, change any test sequence for you. So we have most of the basic units that are out there, but we still have a new customer once in a while. They're like, hey, do you have this one? And we'll be like, no, but send us the service manual, we'll write it for you. Our turnaround time is usually a day. It's pretty easy for us to do it because we have the tools to kind of facilitate the writing of it. A lot of times it's like a new version. So for example, the 3015A, there's a new version of that. I can't remember the name of it. We didn't have that one a year ago when we found a new customer that had the newer versions of that 3015A. So we took the 3015A, adjusted it based on the latest service manual. It had, a few changes in it, and then created a new sequence for it. Again, like patient monitors, we have a lot of them, but we don't have all of them, but we'll do it. There's no charge ever. And as long as you help us find the service manual and are willing to test it afterwards to make sure it's correct, we don't want people just using it. We want them to kind of audit it against the service manual the first time. And then once we kind of get it validated, then we'll make it available to everybody. And again, they're real easy. We email you a file, you connect the SmartTank to a USB, drop the file into a specific folder on the SmartTank, and it just shows up as a test sequence ready to go.
Okay, another question we had come in is, does the SmartTank need to be sent out for calibration?
Yeah, we get that question a lot. You do have to send it to us, and the reason is our flow meter is very sensitive, and people don't have the ability to calibrate that. It has over, I think, 40 or 50 calibration points in it. We have an automated system. So we know that's a pain. We recognize that people don't like to send out their devices, but our commitment is once you get an RMA from us, we will have it back to you within 2 weeks at the latest. Most of the time, we will turn around in a day or two. And that's our commitment, and we're very good at it. Customers don't usually find it to be a problem. The other thing we do is when you send it in, it's a one-time fee of, I'm trying to think here, of $295. And it gets you all 3 of those devices calibrated. There's not like a separate fee for each one. It's just the whole SmartTank together. And then the SmartTank comes with a 1-year warranty. If you send it in for your annuals, we will extend the warranty another year, and we'll do that 3 times. So you can actually get a 4-year warranty on the SmartTank. When it comes in, we'll update firmware as needed. We've only had 1 update in the last 2.5 years. And that was just to add functionality to something, not fix a bug. But we'll make sure it has all the latest and greatest. If your battery's having problems, we'll replace it under warranty, that kind of stuff. Great question.
Okay, I'm hearing a beeping in the background. I don't know if you...
It's my device. It thinks I stopped breathing and I'm dying. I think all these biomeds know what that's like.
Yeah, I'm getting some alarm fatigue, I think is what they call it.
Yes, I turned it off. Hopefully it's better now.
Another question was, do we have to use your gas bottles? I guess
Great
the
question.
bottles.
So unfortunately you do, because you saw the slot where the bottle goes in. We had to standardize on one size bottle because gas can come in like hairspray cans, paint cans, these propane-like bottles, the fat bottles. We standardized on one package. We also have a RFID tag on the bottles. Those RFID tags tell the SmartTank what gas it is, so it knows if you've got the right gas, and also tell you, the lot number, expiration date, all that goes in the test report. So we know people are concerned like we're gonna nickel and dime you like a printer ink or something, but our commitment is we will always meet or beat any price on gas bottles out there. as long as we're talking about apples to apples on the volume. So let me just clarify that. If you have a hairspray bottle of, let's say, an anesthetic gas, and it costs $150, and our bottle is, say, $295, it appears like we might be more expensive. But if you go look at the pressure in that bottle, it's only maybe 20 PSI, and we're going to be 200 and something PSI. And so when you start to look at based on the size of the bottle plus the pressure in the bottle, we're a way better deal, and we will always be a way better deal. If you can find it cheaper somewhere else, we will meet that price. To date, in over 3 years, we've had one person ask us to price match something, and when we looked at it, we just gently reminded them it's based on actual volume. Turns out that the price, he was paying twice as much as what ours was because their pressures were a lot less than what we have. And so once we showed him that, he was super ecstatic to realize that we were still a way better price. Even though we cost a few more dollars, we were a lot more gas.
All right. I think that's all the questions I see that we have. So I want to thank you, Brent, for your time today and a great presentation. I'd like to encourage everyone to visit lifesparkmed.com to find out more. I didn't forget about the trivia question. The correct answer is the year of the snake. And today's winner is Troy Meeks in Iowa. Congratulations, Troy. Now, a quick reminder that you can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed in 1 hour. You must complete the survey to receive your 1 CE credit from the ACI. You will be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us through email at webinar@ndpublishing.com. Thank you, everyone, for your attention today. Thank you, Brent, for the great presentation, and have a great day.
Great, thank you.